Okay, statistics here is section 2.7. Assessing a regression model. Okay, so what does that mean? That means I had a scatter plot. You don't have to write this in your notes if you want. And I put a line through it and I called it y hat equals a plus bx. I'm deciding if the line was a good idea or I'm assessing how well the line fits the data. When we make a line like this, we're doing it so we can make predictions. And I'm doing it to decide, hey, how good will the predictions be? Basically, that's the idea. Okay, so a little bit of review here for a second. A scatter plot uses these variables on its axes. Okay, so I actually do want you to draw that one in there. The horizontal axis is the explanatory variable. You guys already know that. And that one is an x, so I'm going to put an x on my x-axis. And on the vertical axis is the response variable, right? You know that one too. So that's usually the y variable. So I put x, y points on my scatter plot, right? That's what I do. I put x, y points. Each point is an x and a y. Those are actual data values. Of course, this would be list 1 and this would be list 2 if I was doing that in the calculator, right? Okay, so this is new. A residual plot. A residual plot. Now, you've learned how to find a residual. A residual, we'll write it in a second, is y minus y hat. Okay, it's the distance between a point and a line. That's what a residual is. We've worked with that for the last couple days. Let's make another scatter plot. A residual plot uses these variables. The horizontal axis, we stay with the explanatory variable x. So I am going to put an x here, that's L1. But the vertical axis is not y. We graph all of the residuals. That is, as you might recall, y minus y hat. So I'm going to put the residuals here. Okay? That means for every xy point that I have, I'm going to take the y and I'm going to subtract from it y hat. Well, how would I do that? I make a line in the first place. I make a y equals a plus bx line. You learned how to do that already. I put each of these x's into x, and I get a y hat for each one. So then I'll have a y, and I'll also have a y hat because I put those x's in the equation. I subtract them and I get a residual for each one, and that's what I graph here. This will always be on the line. Right in the middle is the line y equals 0. Because look, you got points above the line and you got points below the line. These residuals are positive, these residuals are negative. So I'll always have positives and negatives because I'll always have points on either side of the line. You know why? We draw a line right through the middle. So some are above, some are below. We'll have some that are positive and some that are negative every time. Okay, now here's some data to talk this through. Here's an activity I did last year with Uno cards. I basically shuffled them all up and somebody rolled 2 dice, I think, to see how many seconds they were allowed to like flip Uno cards. And so they flipped them with that many seconds to see how many even cards they could get. So somebody had 9 seconds and they only flipped over 4 cards. What a loser. Somebody else had 22 seconds, they flipped up 12 even cards. So they kept flipping, and like the draw twos and the skips, those didn't count, just even numbered cards. So here are amounts of times and numbers of even cards that came up. I put that data into a software program that we have at school here. I can't have you guys put it on your Chromebooks though, because why would anything make sense? So anyway, I made a scatter plot out of the data. Clearly a positive association, clearly linear, somewhat strong, no outliers. And then if you look right here, you might have to zoom in on this, or take a look at the notes and zoom in on the notes as a JPEG or PDF file, whatever. You can see the actual equation of the line. So the least squares regression line is given to us in the bottom of this picture. It's right there. Y hat is equal to negative 5 point, I'm going to go 26 plus, I'll just go 2 decimal points, 0.84x. I rounded those to 2 decimal places. So I'm supposed to predict, as a result of that behavior that I got from my classroom here, I'm going to predict for 9 seconds. Now look, I'm predicting for something we already know. Somebody took 9 seconds and they got 4 cards. But compared to how everybody did here, I'm going to predict what we think we would get for 9 seconds. So that goes y hat is equal to negative 5.26 plus 0.84 times 9. So I'm going to get out my calculator. And I'm going to say negative 5.26 plus 0.84 times 9. All right, I get 2.3. Y hat is equal to 2.3. So, as a result of how everybody did and me putting this line in the middle, I put that x into this equation and I got 2.3. The actual x was 4. So, y minus y hat is going to be, I'll write it again, y minus y hat. And then I'm going to say the actual y, which is right here, it's 4, minus the predicted y, which we just did right here, it's 2.3, is equal to 1.7. I have a residual of 1.7. It's positive. That means the point was actually above the line. And if I look at my little graph here, 9, 4 is right there. That's the 1.7. That little distance right there is 1.7. Okay, go to the next page.